let's take a look at an example of calculating global extrema, and that'll hopefully put things, kind of bring things into focus for you. So we're finding the global extrema over the interval 1 is less than or equal to x is less than 3. So you'll notice it's closed on the left, open on the right. So the first thing that we need to do is consider our endpoints. Like, we know that those are two places that might be our absolute extrema. So let's calculate those endpoints. So if I plug in f of 1, we're going to get, what is that? Plugging in 1, I get -1 plus 3 minus 2. So 3 minus 2, that should be 0. So f of 1 is equal to 0. And if I plug in my f of 3, I'm going to get -2, yes. So I considered my endpoints. Now I need to look for my critical points. So I need to solve for my critical point first. So I need to solve for the derivative. It's going to be -2x plus 3 minus 2. And then minus 0. And then if I set that equal to 0 and solve for x, that will give me my critical point, which is going to be x is equal to 2/3. So then f of 2/3, I calculated that earlier and got 1/4. Please check my math on that if need be. So now, we had said before that the global extrema have to either occur at the critical point or the endpoints. So once we've calculated the y values for all of these, we literally just compare them. So which of these is the largest? X equals 2/3. So that means the point 2/3, 1/4, because they're asking for the global extrema. That means they want the point, so we need to give the x and y value. This is the absolute max, because it was the biggest of those three values. Now if we go x equals 3, so that would be 3, -2. This is the lowest point. However, if we look back originally, notice 3 actually isn't in our interval. It's an open interval. So this means, because it would have occurred at 3, if we could get to 3, there is no absolute minimum. Because we can always pick a number slightly closer to 3 and consistently get a slightly smaller value. And we can do that infinitely, so none of those values are smaller than all the previous ones, because I can always come up with a new value that's smaller than whatever my previous smallest one was. Weirdness with infinity, I know, but that's sort of the rule of it. Let me know if you have any questions, but this is basically how you're going to always find global extrema from like an algebraic calculation standpoint.